All right. Well, hello everyone, and welcome back. It is me, your favorite Jackson. I hope. Sorry, I have been out for the last like couple weeks, or well, we've been off and on for the past few weeks because I have had some pretty substantial internet problems. Like not having internet at all. So that is kind of a problem. But now it's back. So here we are. We're not doing this via phone, like via cell phone, like we did with Jeffrey J. Louder's interview. All right. So, joining me as always is my host and co-host Peter. Welcome back. I think you're
Oh, you're
muted.
mute.
I
Yeah.
I am muted,
And also we have
which
a
is which
secret
is
Nestlig.
which is my
Who you
best
heard.
side if I'm muted. Okay.
Oh, I don't think so, Peter. I enjoy hearing you. Hello, Nestlig. How are you doing?
Doing great, thank you. And finally back after 2 weeks. Yay!
Yep.
Oh,
Yep.
for me it was 3 weeks, was it? For me, yeah. For me it was
Yeah.
3 weeks. And for you, yeah.
Mm-hmm. Yep.
Time
And
flies.
then,
Time flies by.
yep, when you're having fun, right?
But
Or something like that, I guess.
we mostly do with the content that we have, right? I mean,
Yeah. So let's see. The last talk we did was with Jeffrey J. Louder, our philosopher friend, and that was a lot of fun. I hope we can have him on again in the future, maybe with fewer internet problems. Um, and then other than that, just haven't done much. However, I am very unhappy to report that Stephen Meyer went on the Joe Rogan podcast. Um, well, it was released today. I don't know if he went on today or went on like earlier this week and they just released it or what. But they just dropped it a few hours ago, and that's awful. I hate that. That's the worst. Um, first, Joe has on an anti-vaxxer a few weeks ago, and now he has a creationist on. So that's great. He's just going through all the different reality deniers. So moon landing hoaxer next. Why not? Flat earther? Have him on. Let's do it. It's only the world's like largest platform. Who cares? Whatever. Anyway. All right. Let's see. Who do we have all today watching? We have Trail Mix saying meowdy. Trudy Stubbs says hello, hello. Jamie E said, Smitty, sorry. Smitty says, I'm sure an online Hogwarts sorting hat quiz will have more academic rigor. You're probably right, Smitty. Jamie E says, hey, all. And Icarus says, having internet is overrated. Maybe. I mean, if I don't have internet, I can't see all the stupidity that exists on the internet. So I guess that's true. So there's that.
on the other
But I
hand,
also don't get to interact with all you guys.
if you're on Twitter, it's kind of overrated at the moment because that's turning into a cesspool real quick.
Oh, and Brian Stevens.
And we have
Brian
Stevens.
I'm going to tell you, everybody told me how like complicated Mastodon was. I don't know if that's true, but they said it was complicated. However, I am also on Threads now. Threads is my second. It's like my Twitter clone. So I'm kind of over there now. We'll see if it lasts. It seems to be gaining a lot of people right now. And the great thing about Threads is they don't want Nazis on their platform. So there's that. Anyway.
Yeah. Those are Elon's favorite people these days. I mean,
they certainly are. He really does enjoy putting or giving them a megaphone so they can shout all kinds of like anti-vax and racist nonsense to the universe. He just loves doing it. It's his favorite pastime.
I'm still curious because we do still have Twitter in Europe, but we might not have soon because they gave him a warning that he needs to clean up the platform. Otherwise, it's going to be blocked in the entire EU, which is probably going to be good for advertising. Although I don't know if you've
in the EU.
I don't know if you've seen it. He's already messing with his advertisers. His advertisers get a kind of a placeholder that they can put in a tweet and then put their content in that placeholder. And one of the latest nice tricks of Twitter was that they screwed that up. So if the advertisers would have an advertisement, they would just post a link that goes back to Twitter, which I don't know. You want to pay for that?
Yeah.
Yeah,
He's been chasing away advertisers since he bought the platform because, they're just like with the EU, they see how much of a cesspool it's becoming, and so while it's still a very large platform, just like Facebook. Facebook is still also a very large platform, but yeah, a lot of it makes a lot of people really nervous when you're like giving Nazis megaphones all the time. That doesn't vibe very well.
And another thing is that people have to sign up and make an account in order to see the advertisements. Also not a good move.
Right, yeah. DM, what use is half a wing, aka DM wing, says, why wouldn't you want National Socialist Workers Party members on your platform? Gee, I can't think of a reason. Smitty says, I've listened to a bit of Mastodon. I don't know how complex their songwriting is. Wrong Mastodon. We're talking about the elephants.
Yeah.
All right. So today, as we give ourselves lobotomies once again, we are going to be reading or taking a course, and I use course so loosely it basically doesn't mean anything.
You need multiple quotation marks. There.
Correct. You need like quotes within quotes within quotes. Yeah.
It's kind of using
from the Discovery Institute.
It's kind of using the word social media for Twitter because it's not that social anymore.
Right.
No, it's antisocial.
It's antisocial.
The anti-social media platform.
Yeah.
I feel like I'd sign up for that. That sounds like something I do. Yeah. So the funny thing about are mastodons actually elephants? Well, they're in Elephantidae, so it depends on how you use the word elephant, I suppose. If by elephant you just mean like Loxodonta and Elephas or extant elephants, then no. But if by elephant you mean Elephantidae, then yes. So it just depends. Just depends how you use it.
That's every answer you give for cladistic. It depends on what you mean by bird. It depends what you mean by reptile. It depends what you mean by fish.
Yeah. Right, exactly. Yeah.
It's all fluid.
Says, I heard lobotomy. What did I miss?
Yeah, so I recently watched
intelligent design literature.
I recently watched an old video of Kent Hovind, and remember when they had this great argument that there are no changes in genetics because the information is already there. If you take a dog and you bring it to let's say Alaska, colder environment, the dogs will with the thicker hair will survive. That's not natural selection. That's just in the genetics already. And then the dogs with less hair will die off. Guess what he says about mammoths? They didn't have a lot of hair because they were living in a cold environment.
You're right. Yes.
It was
You're right. Yeah.
Yeah.
Because I debated him and he said that. I heard him. I watched a lecture of his and he said mammoths weren't cold weather animals. And I was like, the heck is he talking about? And so when I did a debate with him, I said, like, okay, what was your reasoning for that? And he said, oh, well, they don't have sebaceous glands. Literally 10 seconds of Google searching. Oh, look, mammoth sebaceous glands identified in specimen from Russia. It's like, dude, you didn't spend 10 seconds.
I loved his argument where he said the long hair was purely cosmetic.
And you know what else is funny about that? If you look at their diet, if you look at their gut content, it's Arctic plants. If you look at like the pollen in their feces or in their teeth, whatever, it's Arctic plants. If you look at the strata they're associated with, it's Arctic plants. Like, what do you want?
But they had tropical flowers.
The Arctic plants weren't Arctic also?
Didn't they have tropical flowers still in their mouth and in their belly, as Kent Hovind stated?
Of course they did. They had palm tree. They had watermelon in their gut. Yeah.
Yeah.
What was it? There was a creationist on Twitter who said that the Younger Dryas was when the global flood happened, and I said the Younger Dryas, the time period named for a terrestrial flower, that's when the global flood happened. Okay, all right.
Oh, I had a
It's
better
called-
I had a better one that I still want to reply to. There's a guy on Twitter who said, so the younger layers are the newer ones, and the older yeah. So the younger layers are on the bottom, and the
I see.
older
Okay.
layers are on top, because that's how it
Mhm.
works in humans as well. You're born, and that's on the bottom, and then you grow older
no.
and older as you go to the top of where you are now. So that's why the younger layers are on the bottom.
Peter, listening to that took years off my life. I just want you to know.
I need to reply to that, but I had to work up doing that because it's going to take years of my life as well.
Yes, Dalton, literature in lots of quotes. Is DiscoveryU of university kind? Okay, well, it's like PragerU. PragerU is not a university; it's a YouTube channel, or well, they probably have their own website, but you know what I mean. They put their stuff on YouTube, and their courses are just YouTube videos, and that's it. So the funny thing about the Discovery Institute is you could already say it's a school, right? It's the Discovery Institute. An institute is like a type of university. So why don't you just keep that? I don't know.
I still think that it's different, Jackson. It's Discovery U, and I think the U stands for uneducated, and that would also apply to PragerU.
Right.
I think that's how we need to see this.
Correct. I'm in favor of that, Peter. I can't argue.
See?
So the so PragerU, it's not an actual course. They just have a lot of times just like random conservatives to make bad arguments for them, including Stephen Meyer. Because don't forget, at the end of the day,
it's a small world after all.
Correct. At the end of the day, for the Discovery Institute, as we know from the Wedge document, which was accidentally leaked back in 1999, the end goal for intelligent design is theocracy, which we're not close at all, or not approaching in any way, I guess, in the U.S. Laughs, sadly. But their end goal is theocracy. They want to roll back like women's rights and all that fun stuff, and not let people learn about evolution and the old age of the universe. And they want to like destroy, basically any philosophy or religion.
But remember, they are for academic freedom.
Of course they are. Of course they are. Only when it's theirs, though. And so this DiscoveryU, which we found out like a few weeks ago, is the Discovery Institute university, but it's not a university. It's YouTube courses again.
Again, we need more quote marks.
Yeah.
Always.
So the way that they structure,
we
can't put enough of these around it.
We also need oven mitts, because I feel that there's a lot of face palming coming, so we need to protect ourselves with an oven mitt.
Probably.
We need how do you call it in English?
What?
Like those little clips you use to hold your wet clothes on the line.
Like a paper, or sorry, not a paper clip, like a little, like the little wooden clips.
Yeah. We need those to close our noses, because we are about to handle some hot steaming pile of BS.
Mm-hmm.
Correct. Yep. Exactly. Mm-hmm. We're about to get a what does it say on the thing, Peter? It says we're getting a load of BS in science. Isn't that what it says?
Yep.
I think.
Well, that was your sentence. I asked you what you wanted to have. You wanted a certificate, and so I made the certificate, and it's a lot of BS.
Pen. Somebody's right. Yeah, Smitty and Jamie. Clothespin. Yeah. So yeah, so they've just taken their arguments that have been around for what 20 plus years now. It's the same creationist tripe we've seen, before, although they've got some other really funny arguments sprinkled in. Correct, Icarus. So we so we're just gonna go through it, rebut their arguments. We're gonna go through sections 4 and 5. Section 4, let me look back at it again, is common descent.
Icarus is wrong though. He says wascheklemmer, but it's actually wasknijpers, and I think Nestle can confirm.
That's German what Icarus was providing, of course.
Yeah, but I mean, it's it's wasknijpers because the English can't say that.
Yes, yeah, Dutch. Yeah.
And then we'll go through section 5, which is pretty short by comparison. So really, section 4 is like the meat. So the only one we're doing is the free one because we're not paying these hacks. They don't deserve it.
No.
So we're gonna do discovering intelligent design, which if you want to follow along at home, feel free. It's the free one. They don't charge. They won't take your credit card information or anything. Of course, they actually have a section at the end that's called academic freedom.
Well, is it truly free if you are paying some brain cells?
That's very fair, Nestle. And we're paying time also. We're spending our time here. We're wasting it on them. So section 4 has 4 chapters in it. We're going to look first at chapter 13, objectives and outline, which is tree huggers. And we're just going to go right through it, section by section. So
I put the link in the chat for people who want to follow along. So
for those of you who want to follow along at home, feel free.
Yeah, at your own risk. Okay,
at your own risk.
Want to start it off? We're starting off with the introduction video, right?
Chapter 13.
We're going straight to 13.
Can you get the video?
Well, yeah, the introduction video of the course. I had that downloaded.
Oh, okay. Oh, I didn't. Oh, okay. All right. I thought you said you couldn't, but that's fine. All right, we can do that. Yeah.
No, there's an introduction video for each chapter. This is the introduction video for the entire course. If that makes any sense.
I don't care about the whole. I don't know. I don't really care about the whole course.
Well, we can
like 9 minutes.
Yeah, we can start it and see what happens. If it's not good enough, we could just skip and go on to.
Okay. Yeah, we can start with it. That's fine.
Okay.
Okay.
What have you already heard about intelligent design? In this first section of the Discovering Intelligent Design course, we're going to introduce the theory of intelligent design, as well as the theory of Darwinian evolution,
not even a hypothesis,
and also introduce some basic terminology that is common to this debate.
Wow.
Since the dawn of human history, people have looked up at the night sky and wondered how the cosmos came to be. Turning our eyes to more earthly matters, we pondered questions like, how did the first life arise? How did intricate abilities like sight and hearing develop? Where did our own species come from? Discovering Intelligent Design examines modern scientific evidence to answer such.
Now I feel silly because this is a missed opportunity. I should have taken the blackboard and should have written on him, don't listen to this hack, listen to Jackson Wheat. That would be a good. Damn, I did not see that.
Fundamental
it's okay.
questions.
There's always next time.
In chapter 1, we're going to define the theory of intelligent design, which studies indications of design in nature. Intelligent design is a scientific theory which holds that
really
many features of the universe and life are best explained by an intelligent cause. ID scientists seek to distinguish between intelligently caused objects and events and those which originated via unguided processes.
And they haven't done that to this day, by the way.
Experience shows that many elements of our everyday lives, such as language, codes, and machines, depend on information produced by intelligent agents.
Wow.
So how do we detect design? We detect design by finding specified complexity in living organisms. Specified complexity is a property exhibited by an event, object, or sequence of information that is unlikely and matches an independent pattern. ID theorist Stephen Meyer explains.
Okay, so just want to throw this out there. They have failed consistently for the past several decades that the Discovery Institute has existed to define specified complexity. William Dembski, who was the guy who came up with the term, did not have a working definition for it, and by the time he died, he didn't have one. All the definitions.
Just like it's like I have a very interesting sounding terminology. What's the definition? I forgot about that.
Well, he tried to apply different definitions, but every time he did, there was always like exceptions, or there was no way to like map the idea beyond like the thing that he was looking at specifically to like apply it more broadly. There were no mathematical explanations for how to apply it, or there's no way to rigorously apply it across genetics, things like that. Tony Reed did a video about specified complexity in which he went to great lengths on all these issues, but Dembski never came up really with an idea, and now I don't even know if Behe's even trying with it. There's really no definition for it. Specified complexity doesn't really mean anything. It's just a buzzword, just a fun sounding buzzword.
If you ask, look at this sequence of DNA, how much specified complexity is in this sequence and in what units? They cannot provide an answer. Yeah.
Right. Yep. And we've talked about this before. We've done talks with actual creationists about this and gotten them to admit the same thing. So yeah, nope. Specified complexity does not mean anything. It's not a term used in any actual science. It's just a term they came up with that they don't have.
To sound smart. Yeah, it's a sound impressive word. Yeah.
Yep. All right, we can keep going.
Yeah. So one quick thing. People in chat were doing it. I can do this actually. I can do. Hold on. Yes. I can do better than that. Wait.
Well, Peter, I don't have a button like that on my end, so I can't.
Okay.
I can't do that. I don't have a button like it, but I would if I could.
Okay, let's continue.
That language, machines, and computer codes are prime examples of design objects with large quantities of complex and specified information.
We know they were designed.
As Dr. Meyer has written, our experience-based knowledge
pause for a moment. Pause. He claimed that those things contained large quantities of specified complexity, but he never explains how much, or he doesn't even give examples of those for how you can measure this thing.
Don't you know
there is no example of how you measure
specified complexity. It just contains it just inherently. just by its existence. I'm curious, actually. I wonder if they process of intelligent design. Oh, I can define complex and specified information. Oh, do they do that? Do they actually attempt to do that?
In the course material.
Oh my God, this is their example. Okay, so I'm just peeking over at the chapter 1 in the section 1 because it says in the objective, I can define complex and specified information and identify different types of information as complex, specified, or complex and specified. Do you want to know what their examples are?
No.
Complex but not specified, random mixtures of organic polymers, specified but not complex, salt crystal, both complex and specified, living organisms. Complex and specified information, a property exhibited by an event, object, or sequence of information that is unlikely and matches an independent pattern. There's so much nonsense baked into that definition, and their examples are absolutely garbage. Why am I not surprised?
I'm just more confused. Like they gave examples, but it doesn't really make anything more clear.
Right. Okay. What is the difference between complex and specified then? What does complex mean? What does specified mean? How is a living organism both complex and specified? None of this makes any sense.
It's a specific
That's
organism.
it. That's literally it.
It's a specific organism, and how it came to be is too complex. So that's basically 9 out of 10 times that's their reasoning.
That's literally it. There's nothing else. I mean, they jump to like ID and religion next.
And there's no definition, or it's just examples.
A property specified. I'm sorry, I can't speak. A property exhibited. I saw specified. A property exhibited by an event, object, or sequence of information that is unlikely and matches an independent pattern. How are you determining whether a sequence of nucleotides is unlikely? How are you determining whether any part of a living organism is unlikely? Or whether it matches an... How does a Golgi apparatus match an independent pattern? That's what I want to know. What does that even mean? What qualifies as an independent pattern?
So, if I have to hazard a guess, unlikely means that the odds are really, really small, and for them to create those odds, they use completely weird calculations, because the odds are 100%. The odds are 1 because it exists.
True. Vandalia for 1998. Vandalia 1998 for $1.99 says, "Are you getting a degree from this beloved university?" Yes, we are. We're all getting certified today. We're just as committed as the rest of you. So we're certified together.
If maybe I can do my best in guessing what they mean is like, imagine if you like shuffle a deck of cards really good, really thoroughly, and you lay them out in a sequence. That sequence is like purely random, and according to Shannon information, it contains the maximum amount of information that you can get from a random sequence like that. It's the most information contained within that sequence of all possible sequences. But according to the Discovery Institute or something, they will say like, oh, sure, this is Shannon information, but it's not specific. It's not a specific pattern. It's just a random pattern. So they will say, oh, it doesn't mean anything, and they want to have some meaning into their definition. But of course, they don't define what they mean by meaning. That's what I think. Yeah.
I think they try not to think, because if they do, then they'll realize it's wrong. Critics conflate ID with creationism. No, that would never happen. That's crazy talk. Weird. That's literally it. It's kind of amazing. Other scientific fields use ID reasoning: archaeology, forensic science, and environmental science. What dishonesty! What abject dishonesty! When archaeology is talking about, like, a pot or a shovel or something that was designed, it was by a human. They're not implying that the universe or organisms were designed by like a mega human. Okay? So saying, oh, it's just ID, it's not. It's not just ID, because if you're going to say that intelligent design means human design, then who is the human that designed life? Because they all agree that life was designed. Oh, but it wasn't a human, it was God. Okay, then we don't use that in archaeology?
The only stretch you could make is that archaeology does sometimes do research on certain hills because they're man-made. So that's how far it goes.
And you know what the funny thing about that is? When archaeologists and like anthropologists are looking at like tools in the record, things like that, having to figure out which objects in the fossil record are like natural caused versus being man-made
Mhm.
can actually be rather difficult, right? So like flaking rocks, right? Which types of flaking maneuvers are possible to be caused by like erosion versus which ones are human caused, right? And that can be difficult.
Is
But
making the
how do you
distinction
tell?
that is making the distinction between created and not created.
Yeah.
Because you have the flaking that will happen through natural causes. Those are not created.
Right. I mean, same for life. No one's looking at life and being like, wow, who created this? No one did.
Yeah.
So if you find a way to, determine who the creator of the cell was, then, get back to me. Good luck with that. But no one's done it yet. So have at it. Anyway, I guess we can continue.
Okay.
Flow confirms that systems with large amounts of specified complexity, especially codes and languages, invariably originate from an intelligent source, from a mind or personal agent. As this book will show,
in fact say that.
Specified complexity is an indicator of design, and it is found throughout nature, from the constants and laws of the universe down to tiny molecular machines inside the cell. Not everyone, however, accepts that ID provides a valid scientific explanation for these observations.
Nope, it's not.
Many ID critics claim that ID is merely religion or a form of creationism, the belief that the universe and life were created by God as described in the Bible or the book of Genesis. Intelligent design is different from creationism because it begins with our observations of nature rather than the Bible or some other religious scripture, and it limits its scientific claims to what can be learned through the scientific method. As a science, ID refers only to an intelligent cause and does not attempt to establish whether or not the source of the intelligence is God. In our culture, there is a great deal of resistance to the evidence for intelligent design. Much of this resistance comes from those who accept an idea known as materialism, the philosophical belief that the material world is the only reality which exists. According to this philosophy, the universe and all life are products of long chains of blind, unguided, and chance accidental events. This book is going to analyze 7 tenets of materialism to see if they are correct.
It's not a book, it's a course.
Materialists have been around for millennia, but for the last 150 years, they have relied heavily on the theories of the British scientist Charles Darwin to validate their philosophy. In Chapter 2, we'll introduce Darwinism and the theory that all life shares common ancestry and evolved through descent with modification driven by an unguided process of natural selection acting upon random variation. The problem for Darwinism, or its modern form of neo-Darwinism, is that biological organisms contain many complex features that cannot be built through numerous successive slight modifications, a requirement of Darwinian evolution. To help separate opinion from fact, 2 more terms must be defined. First, there's microevolution, which is small-scale changes in a population of organisms. Then there's macroevolution, where large-scale changes in populations occur, including the evolution of fundamentally new biological features.
That's not
Typically,
what that
the term
means.
Macroevolution
Dat was
also means
still
who's
the definition
from
this
a single
time.
common ancestor through unguided natural processes. This leads us to 3 common definitions of evolution. First, there's evolution number 1, or microevolution, which again is small-scale changes in a population of organisms. Then there's evolution number 2, or universal common descent, the view that all living organisms are related and are descended from a single common ancestor. Finally, there's evolution number 3, or natural selection, which is the view that an unguided process of natural selection acting upon random mutation has been the primary mechanism driving the evolution of life. Sometimes evolutionists purposefully confuse these definitions, hoping that you won't notice they've overstated their case.
They're not definitions.
Those are all
for an
true
evolutionist
things.
to take evidence for microevolution, or evolution number 1, and claim that it supports common descent, evolution number 2, or development through solely unguided mechanisms like natural selection or evolution number 3.
I mean, both of those are part of
This is why
the whole
critical
process?
thinking is a vital part of exploring the disagreements between materialism and intelligent
Let's pause
design.
for a moment.
Here are a few.
Let's pause. So Casey Luskin saying critical thinking is important is kind of hilarious because he's a major hack. If you guys have watched the Professor Dave video about Casey Luskin, and say what you want about Professor Dave, but the video he does on Casey Luskin is extremely good because Luskin lies. Luskin gets caught in a flat, bald-faced lie. And the funny thing is, if you look at I think Beckley, I think it was Gunter Beckley. If you look at Gunter Beckley trying to like run defense for Luskin, he basically ignores it. He's like, something else. Don't worry about it. Because he was caught in a lie. Luskin said that Owen Lovejoy changed Lucy the Australopith's pelvis to make her a biped. He said that Owen Lovejoy, a paleoanthropologist, changed Lucy the Australopithecus' pelvis. Now, he didn't. That didn't happen. What happened was they made a cast of her pelvis and saw that her leg or the joint or whatever was like
the hip wouldn't fit
her pelvis.
Yeah, the hip wouldn't fit
because the femur is like embedded in the hip. Basically, it was like crushed into it, which you couldn't walk if that were the case. It would be physically impossible to walk. And so they took the cast of her pelvis and mirrored it on both sides instead of it being crushed on one side. And she would have been a biped. We also know this from her knee, from where the foramen magnum is in the skull. And also we have other like species of Australopiths that we can compare her pelvis to, which don't have the crushed pelvis, and see that Lovejoy's reconstruction was correct.
Yes.
So, yeah, Casey Luskin does not do critical thinking. He just does lying, and then says those who don't agree with me don't do critical thinking. So, just throwing that out there.
I want to add, I loved what he just pointed out. So, evolution 1 is microevolution. You have a population that undergoes a small change, which is microevolution, which happens according to these people, but they don't have common descent. How does that? So how do you get a population that undergoes a small change, but now their ancestors are no longer their ancestors? I don't think they've thought this through.
I don't know how that works. Well, and of course, microevolution happens in part because of natural selection. So when he's saying, oh, they use microevolution to justify universal common ancestry, well, that's part of it. That is a root, because if you don't have a mechanism for how evolutionary change occurs, which is on the scale of microevolution, then you can't get to macroevolution, and thus universal common ancestry wouldn't matter. But since we do have the mechanisms, we can extrapolate from microevolution to macroevolution, and indeed at this point we've literally observed macroevolution happening on human lifetimes, because it's not large-scale changes, it's genetic change at or above the species level. And so we've literally observed it now. We know this happens. And we also have a really, really good fossil record for organisms like phytoplankton and certain like invertebrates, where we can see how they speciate like over thousands of years. You can see the gradual changes. And so, I mean, microevolution is part of the process. It's part of how we reason to universal common descent, but they're not interchangeable. And it's kind of silly that he acts like people are interchanging them, because they're not. So, whatever. We can keep going.
Okay.
Few tips for avoiding logical errors as you investigate this debate. First, you should question assumptions. Though materialists rarely if ever acknowledge it, nearly all of their claims are based upon assumptions. They typically assume that their theories are correct and then interpret all evidence based upon their assumptions. Very quickly, assumptions become facts, and
it's a lack of self-awareness.
Lack of self-awareness.
With those facts. Treating assumptions as fact will often lead to circular reasoning, which is an invalid type of reasoning where the rules of starting assumptions permit only the desired results.
Probably the homology
thing again. An example of this type of reasoning is as follows.
Can I just interject? So, assumption, you couldn't make assumptions. So, if you assume that there is an intelligent designer, it will lead you to false conclusions. He's basically ruining his own statement, his own position, because they assume an intelligent designer, don't they?
That's true. They do that
because there's no evidence for one.
Presume that the only reality is the material world. Then they claim that anything beyond material causes is unscientific. Therefore, they say, any evidence that seemingly points towards intelligent design is being misinterpreted because ID, by their definition, is labeled unscientific.
Let's pause. So no, when they're saying like material causes are the only testable causes, it's not impossible for an intelligent designer to exist or for there to be intelligent or evidence of intelligent design. However, the most honest thing we could say is if the intelligent designer is routinely interjecting in something, is we have no naturalistic explanation for some process. That's the most you can say. You can't go any further than that. And there are no things for which that's the case, but that's how it would go. What'd you say?
Oh yeah, yes. I was just basically echoing what you said here. Is that scientists can only investigate like causes or explanations that are that we call natural, because those are the only type that are testable.
Right.
And if you and that's why scientists have to make the implicit assumption that there is a natural explanation to be figured out. That doesn't mean that they will assert that there is no such thing as a supernatural thing out there. That they can still be theists, and many scientists are theists. So it's not the assumption that the natural world is the only thing that exists. It's just the assumption that there is a natural explanation to be found here.
Yeah, what he said is materialism is everything outside of materialism is unscientific. It isn't, but we cannot investigate something that we can't see or detect or measure.
Right.
Everything
exactly. Like, because then what are we doing?
Yeah, we can't do science on something that we can't detect. So it's not unscientific. It's also outside of the realm of science, because science has no means of investigating it. It still doesn't mean that it's unscientific, because maybe someone in the future will come up with a mechanism on how to check things that are outside of the realm of materialism. You don't know, and then it becomes scientific.
Yeah.
Also, like science doesn't like in principle reject design. Like we accept that Stonehenge is designed. We accept that the pyramids were designed. Like we don't like unless you want to posit a vague designer that cannot be tested. That cannot be tested. Then that's the problem. That's your problem. If it cannot be tested, then we cannot continue from here.
And also, you can have accidental design.
That's all they're proposing.
You can have accidental design. I know that Arn Ra brought up at least two. A flock of birds that you see is an accidental design. It's a wavy kind of cloud of birds that you can see. There's also in Iceland the braided rivers, which is an accidental design. The rivers intertwine, come back together. That's an accidental design.
I would use the word emergence, because that's the word that I most frequently see when describing these things. Emergence.
It's an emergence design, but it's accidental. It's not on purpose. There wasn't a designer who dug the rivers in Iceland. That's what I mean.
Yeah.
There's no river digger.
Good. Yeah. Yeah, emergence is a good way to put it. Yeah.
Okay.
All right, we can keep going.
Conclude that there is no evidence of design, and all rational explanations lie within the material realm. Ergo,
That's not what they say.
materialism must be true. But if you noticed, that was established through circular reasoning. Some other tips include demanding evidence and carefully defining your terms. Finally, be sure to always seek the best.
You guys gonna do that?
So what about intelligent design? Yes. Is ID compatible with evolution? The answer depends on which definition of evolution is being used. Intelligent design does not conflict with microevolution or evolution number 1. It does not even necessarily conflict with common descent or evolution number 2, so long as the mechanism of change is not considered wholly blind and unguided. However, many ID proponents, including the authors of Discovering Intelligent Design, are scientifically skeptical of common descent.
They're not
scientifically This more controversial theory will be explored fully in Section 4. The third definition of evolution is where Darwinism and ID directly conflict. Neo-Darwinism claims that an unguided process of random mutation and natural selection was the driving force in the evolution of life. This conflicts with intelligent design because ID claims that life...
Natural selection doesn't say anything in particular about how the mutations arise. So you could have an intelligent designer who, for whatever reason, is making the mutations, and then the mutations are subject to selection. But natural selection doesn't say anything specifically about the origin of those variations. Also, Savage, behold the banana cobra for $2 says, the way they define terms, a circle has corners. That is true. I do agree with that. Yeah. So, yeah, I hope that they define terms, because we already looked at one example of that and it was stupid. So we can keep going.
Life is the result of a guided process where an intelligent agent made life for a purpose. Now that we have defined the conflict between ID and materialism, we're ready to begin exploring the evidence.
All right.
Here I have a question. The intelligent designer made life for a purpose. What purpose?
To worship him, obviously. Because he demands fealty, Peter. He cannot live without it.
What purpose?
It's also interesting.
What purpose did the intelligent designer have in mind when he created a virus?
To screw with the monkeys that worship him, obviously. He said, you know what? There are maybe too many of these monkeys. I'm going to give them virus.
There are going to be too many worshiping me. Let's kill some of them off with a virus. Let's do that.
Correct.
That sounds like a cool idea.
Yeah, this is actually an interesting question. Like I gave the example of Stonehenge previously, and people are still wondering for what purpose it served for Stonehenge. And I think the best explanation I've seen is that it aligns with the summer and winter solstice. I think, like when during the shortest day of the year, the sun rises at a particular site that is aligned with Stonehenge or a specific structure within Stonehenge. So it's probably like a celebration of the coming of the summer or the end of the winter, perhaps.
Yeah, possibly.
Yeah, so but those ideas are testable when it comes to these things. But what about your explanations? Where are your proposals?
Where's the funny thing about ID is like how backwards it is, because simplicity is the hallmark of design. When humans make things, even complex things, they make them as simply as they possibly can, right? They use the fewest tools and materials.
The KISS principle, KISS, keep it simple, stupid. Yeah.
Right. Yeah. They use the fewest materials necessary to construct whatever thing it is. That is the complete opposite of how organisms work. Our genomes are way longer than they need to be. We are full of parts we don't need to have. It's cells, proteins do like way more functions than they should need. When you have like transduction pathways in the cell, you may have one transduction pathway that has like 5 different enzymes which all do the same thing, and that's just getting the message like along slightly further in the cell.
It's also interesting about like many complex or protein complexes in the cell that are seem like they have been like how do you call it, jury rigged together. Like one good example I can give is like the ATP synthase. Like the ATP synthase is composed of 2 main structures. Like if a cell a membrane pore, it's pretty similar to other membrane pores that are just separate from the rest. But then you have the structure, the structure that actually makes ATP. It's homologous to the helicase that unwinds the DNA, I believe, right? I think so. Yes.
Right.
And interesting is that the way the whole structure spins, it's not aligned. But like these structures are not aligned with each other. Like the stoichiometry doesn't match. So when the structure spins, it has to wobble in an awkward fashion a bit to spin around. So it's to compensate for this misalignment.
Okay, interesting.
Yeah,
I like using examples of like, you know, weird developmental pathways that organisms go through, like, you know, flatfish, for instance. You know, why is it they're born looking like normal fish, and then their eye, you know, starts on one side and has to completely shift to the other side. Their skull has to deform after they're born. Like, why? why would you go through that? What's the point? Why not just be born that way? You know, or like with the anabantiform fish, the like betas or the Siamese fighting fish, gouramis, all those guys. When they're born, they don't have the labyrinth organ, which helps them breathe air. It's a modified epibranchial bone in their pharynx. In their it's one of the pharyngeal bones. And so when they're born, it's a normal epibranchial bone, but then it develops all these processes after they're born, as they are growing into adulthood. Again, it's like, why do that? It's such a weird way to do it. Or why give us, you know, why make our anus our first opening embryonically? Why? Just like all other deuterostomes. What's the point? There's no point. If intelligent design is true, there's no reason that had to be done. Just cause. All right. We ready to go to chapter 13 and
we are
do the tree huggers.
Let's hug some trees.
All right. I can't read it really on your screen, so I'm going to look at mine. If you could scroll a little bit down to learning objectives, please.
Hold on.
Okay. So learning objectives. Oh, there we go. Okay. All right. So learning objectives. Number 1, I can explain universal common ancestry as the belief that all living organisms are related through a distinct common ancestor, and I understand that the main assumption behind phylogenetic trees is the assumption that similarity.
Is there a way to zoom in a bit? So sorry.
Can you zoom in a little bit, Peter?
Let me check.
It looks like a little plus sign up at the top.
Yeah, I think so. Yeah. There we go. Yes.
That's better. Yeah, that's definitely better.
Yes.
Okay. Similarity implies inheritance from a common ancestor. I can define systematics as the study of relationships between organisms. I can explain how intelligent design can be compatible with universal common ancestry. Blah, blah, blah. Okay. Okay. Well, here's a more interesting one. I can describe and distinguish between molecule-based trees and morphology-based trees. I can explain how both molecule-based and morphology-based trees assume that greater similarities between DNA, RNA, or protein sequences or greater similarity morphology are said to indicate a closer evolutionary relationship, and that these similarities are said to be derived from a common ancestor. I can explain that while some evolutionary scientists claim molecule-based and morphology-based trees produce consistent trees, much scientific literature suggests that molecule-based trees can conflict with one another when different genes are studied. Whoa, what a concept. And that molecule-based trees can produce trees that are in conflict with morphology-based trees. Okay, so let's talk about that for a minute. Yeah, that's been known for decades, like literally decades. Sequencing genes was first becoming a thing in like the late 70s, really into the 80s. And now we're in the genomic era, so we're doing whole genomes. So it is true that sometimes you can sequence like individual genes and they will give you different phylogenies. And there are a multitude of reasons why this might be the case. Sometimes, they actually mention it shortly down, is horizontal gene transfer. That's one reason. That's true. But the thing about that is horizontal gene transfer events are often trackable, right? So if you see a gene in like, some bacterial group and you compare it with like a gene from another group, you can see, oh, they got this gene from that other group through horizontal gene transfer. That's a thing that happens. That happens all the time. Another one is what's called incomplete lineage sorting. A scary phrase. But basically, not all of your alleles, like not all the alleles for a gene may show the same phylogeny if different lineages split like fairly close in time to each other. And so if you look at like the allele, the gene tree for one particular gene, it may not match for like different species based on which alleles you're looking at, because maybe the alleles are in one species but not another, and so that gives one like a gene tree, but then this other species gives a different gene tree. That happens, and there are ways of working around that, right? You take essentially a consensus of genes, right? So gene trees aren't normally made of just one gene. You compare a whole bunch of different genes between a bunch of different species, and that gives you a consensus usually. Now, again, you can have problems with that, like we discussed in the gibbon's tale, where gibbons have a very complex phylogenetic history because they all diverged right around the same time. So there's a very large degree of incomplete lineage sorting, and it's hard to figure out who's most closely related to who. And even taking the consensus, you have a fairly low consensus which points in any particular direction. But that's not super common. Like, it can happen, but that's not very common. Nestle, you have anything you want to add on that?
I think you covered it pretty well. Yes.
Okay, gotcha. At any rate, the point is simply that, like, saying that HGT and ILS like are things doesn't detract from phylogenetics in any way, and it's really weird to argue that. It's long story short, did that a long time ago when we argued with him about it. Saying, oh, known problems or known difficulties exist, it's like, yeah, we know, we're aware, and what's your argument? So okay, all right, let's keep scrolling down to chapter outline, please. Keep going down, chapter outline.
Yep, there we go.
Okay. All right. Intelligent design does not claim that species are necessarily unrelated, so it could be compatible with common ancestry. That's true. It could be the case. Yeah. We can keep going down. Evolutionary trees, also called phylogenetic trees, are based upon the main assumption that similarity between organisms is the result of inheritance from a common ancestor. Okay. It's not really an assumption. Now, okay, in one sense, you could say it's an assumption, but it's a really, really, really well-tested assumption, right? because if it were just an assumption, would it be used in like murder cases? You know, I mean, you know, or not murder, or sorry, not murder cases. Well, I mean, yeah, that too. Your genes, or you know, if you take a like a cheek swab from someone who's
do
implicated
they
in the
call it
murder,
like a short repeats, or are they
yeah,
called again?
yeah, if you take a you know a swab from someone who's like implicated in a murder, you compare it against like DNA found at the crime scene. Oh, it's the same. Would the intelligent design people say, "Ah, you're just assuming that it came from the same person. You don't know."
I think
No, that's
Nestle
ridiculous.
might be aware of this. We had a murder case in the Netherlands that was unsolved for a few decades. They reopened the case and decided to take DNA from all the males in a particular village in the north of the Netherlands. And even though the killer did not provide DNA evidence, one of his cousins did, and they could figure out that he was the cousin of the guy who killed the girl in this case, which led to the killer eventually surrendering to the police because he knew he was going to be caught based on DNA evidence when he didn't even submit any DNA. So
no, Peter, that's just an assumption. You're just assuming.
Yeah, if that's the assumption, then they tricked him really, really well. But
they sure did. They got him.
Yeah, and if that's the case, if it's an assumption, then how did they get his actual cousin based on the DNA that was found on the body of the girl?
Yeah.
How did they link his actual cousin?
What did you say, Nestle?
I think the same thing happened with the Golden State Killer, which is a case in America that was also solved in a similar way. They got the DNA from some family member, and they figured out that he was the culprit.
Yeah. It's just really funny to me that or you know, obviously paternity tests, right?
Yeah.
Because as Nestle mentioned, the short repeats, this is what defines relatedness, is the fact that the father has this similarity in these repeats to the offspring. That's the whole point, right? And if you want to say that's an assumption, it's a darn good assumption. You could, as Immutable Destiny says, you can figure out the genetic sequence of a person from closely related blood relatives, but it's just an assumption. I mean, okay, if that's just an assumption, all right, fine, you got me. But like, it's a really good assumption. it's okay, whatever. Anyway, evolution.
It's also the same assumption they make. It's also the same assumption they make in like to investigate plagiarism.
Yep. Yes, it is.
Yeah.
So let's go down to building. So part D, number D. This is why I need to be in university. Says that evolutionists often say that different genes produce phylogenetic trees that are perfectly consistent. That can be the case. So there are different. So genes mutate at different rates, right? There are different mutation rates for different genes, or different substitution rates. I guess you would say there are different substitution rates for different genes. And so, because different genes have these different rates of substitution, not every gene will necessarily produce the same tree. No one's hiding that, right? That's not a secret. It's just a fact. that's not. It's not, you know, some kind of thing like you have to drink like blood from a skull and then the evolutionists tell you about it. No, it's literally. I think you should know.
Kalima.
Right. It's a thing I think you should learn, like if you take a genetics course in college. That seems like something they should teach you. But sometimes genes can produce different trees for different reasons. long branch attraction is another reason. That's a problem in phylogenetics, which can produce discordant trees because you have like a small data set for a very derived group of organisms. So which gene you pick might give you a different tree. That happens. And so what researchers tend to look for are what are called phylogenetically relevant genes. And those are genes that are not usually subject to natural selection, right? They're either really like core genes that are, they're genes that are like subject to like neutral mutation accumulation, right? So you can see which species are accumulating, or you can see which genes are accumulating mutations at like the background rate, and then you can compare that between different species. And since natural selection is not causing is not causing particular mutations to be kept or lost, then you get a real sense of just the steady accumulation of mutations. And so those are the sort of genes that or genic regions which are of relevance to phylogenetics, but also ones that are really important. So like cytochrome C is a super important gene. It's used in our electron transport chain, and so like all eukaryotes have it, or almost all eukaryotes have it. There's like a precious few that don't. But it's used in some cases to build phylogenies because it's really good at helping us understand the relatedness among different organisms. I can't think of any really others offhand. Cytochrome C is one. I don't know. But anyway, the basic problem is that biological similarity is constantly appearing in places not predicted by common descent. So what they're doing there is what's called sleight of hand. So when they say biological similarity, what they're referring to is morphological similarity. They don't mean genetic similarity. They're not saying genetic similarity convergently evolves, because that would be quite a feat. Now, what's interesting is if you take, I think it was Preston. I think it was the gene Preston, or sorry, the protein Preston. The gene for it is like completely different from that of, or between like whales and bats independently use Preston for echolocation, and so the protein.
Of course, Preston is already the protein that is all mammals use for hearing too. So it's
right.
So it's just modified to make it more sensitive. Yes.
Right. If I remember correctly, like the Preston gene for like whales, or for toothed whales, like it nests together. All the toothed whales nest together, and then bats like nest together, right?
Yes, I think yeah.
But it's more similar to like the other whales than it is to the bats, even though bats are using it for the same purpose, right? And now that's
you like there are cases where you have like in similar places you have the same type of amino acid substitution that has the same effect, but the overall structure is still similar to their relatives.
Right, yes. Exactly. Yeah, and again, that's in part because, I mean, we only have 4 nucleotides, which are present in DNA, and so there are only so many different possible mutations, which means you can only like have so many possible like changes. But what happens is the genes of these organisms are more similar to their relatives than they are to the other organisms which use the same gene for a convergent purpose. And that's what we expect on evolution, on common. And when I say that, what I mean by is common descent. That's what we expect. If it were the case that like a common designer took the same Preston gene and gave it to both whales, toothed whales, and bats, then we should expect them to be very similar to each other, but they're not. So there's that. So yeah, they're doing kind of sleight of hand here, When they say biological similarity, they're not specifying what kind of similarity. So they just kind of want you to think like any similar feature, whether it be morphology or embryology or genetics. That's what they're trying to get you to think. They're being disingenuous here.
Jackson, the problem is if they're going to be specific, they're going to be caught out much more easily. So keep it vague and then claim that you're correct. That's how it works.
Right. The scientific literature is full of the papers that report contradictions and failures of molecular data to provide a consistent picture of common descent. That depends on what you mean, because if you look at like any paper that's like, where do mammals sit in relation to, reptiles and amphibians and and vertebrates in general, there's really not a lot of debate on that. Like, birds nest within the sauropsids, mammals are sister to the sauropsids, and amphibians are like sister to the amniotes, right? Like, there's essentially no debate on that I'm aware of. So, again, it's like sleight of hand. When they say there's, sorry, when they say there are contradictions, what they typically mean is like with species trees, and that's true, there can be, and sometimes even with larger taxonomic categories. But saying that there are lots of them, like the entire tree of life is in disarray. No, that's just a lie. That's just disingenuous. They're just being disingenuous. Okay, if you could scroll down a little bit, please.
I
want an evolutionary.
Hold on, I wanted to say I like H, because to an evolutionary biologist, a higher degree of anatomical similarity implies a closer. That sentence should be to an ID proponent or creationist, a higher degree of anatomical similarity implies a kind.
Correct.
It's literally the definition of kind. If it looks like the same thing, it's part of the same kind. That's it.
Mm-hmm. Yep.
Okay.
If you could scroll down a little bit, please. Yeah, evolutionary relationship leading to the construction of morphology-based trees. Now, okay, so the question I have for them is, if they think that similarity does not necessarily imply descent, can they give me an example of something conventional science does not think is closely related, or two organisms conventional science does not think are closely related because they are very, very different from each other? Can they do that? I would like to see that. They won't, obviously. They'll never do that. You know what? I say they won't do that. Long story short, did provide the platypus as an example. So maybe. Yeah, Immutable Destiny is right. It's like saying, oh, we don't know the exact pixel perfect description of where some atom in a molecule is, so therefore any molecular structure is just speculation. Yeah, 100%. Look at this. These trees rely heavily upon the concept of homology. I can read, I swear, guys. Similarity of structure and position, but not necessarily function. Yeah, that's true. Much scientific evidence contradicts homology-based arguments. Examples? The development of homologous structures can be governed by different genes and can follow different developmental pathways. Citation. I want a citation for that, but there isn't one. Sometimes the same gene plays a role in producing different adult structures. Okay, that's acceptation. Okay, acceptation is literally part of the neo-Darwinian synthesis. It's literally part of it. I would like an example of the first one. They're not going to give one, obviously. So, like, for instance, I was just reading a paper recently that talked about actually something that Jonathan McClatchy got beat on years ago, which is developmental homology across bilaterians. So if you haven't seen the video, I highly, yes, citation needed, DM, what is half a U swing? What use is half a wing? Yes, correctly. Citation needed. We're going to start saying that. We're going to start saying citation needed instead of citation needed. The different genes. Okay, so McClatchy goes to an event where P.Z. Myers spoke. And McClatchy says, I have evidence of structures of the development of homologous structures governed by different genes. And PZ says, like, citation, sorry. And McClatchy said, I don't remember what McClatchy's response was, but PZ responds with, no, that's a thing I work on. That's not true. And McClatchy kind of backs down, which I know, big surprise. That's what he does. And he just kind of like, oh, okay, well, whatever. And this is the same sort of thing. If you look at developmental biology, the genes that are involved in producing the producing like the blastopore, for instance, in different lineages is conserved, right? The genes that are involved in that are conserved between bilaterians and jellyfish. Okay, the anterior posterior patterning of Hox genes is like the way, if you look, so anterior posterior for bilaterians, anterior to posterior, for bilaterians versus, or head to tail, like the patterning of jellyfish, the way the patterning of these genes is conserved between us and jellyfish. So to say that things can follow different developmental pathways. That happens. That things evolve, obviously. But to just say, oh, some things can change, like, well, yeah, but there's also way more overarching homology in genes than like different genes, right? The blastopore, the construction of the blastopore, the genes involved in that are way more similar, are governed by the same genes, as opposed to like new genes being recruited. So I don't even know. Of course, they're not giving an example. They're just saying it, right? There's no example here. They're just saying, oh, well, sometimes things can happen. Okay. Cool. And I don't know. I don't know what you want. I don't know. Does that make sense? Nestle, am I making sense?
Oh, yes, but I was also looking up something that I remember. I've forgotten the specific name for it. Where is it? Give me a few minutes more. Sorry.
Okay, that's fine. Common design is an entirely reasonable explanation for functional and anatomical similarities. It's not. I mean, it's not unreasonable, I guess you could say, but it also doesn't explain anything, if that makes any sense. Morphology-based trees often conflict with molecular-based trees. Okay. I mean, that can happen, sure. But again, we had morphology-based trees of like where, mammals being sister to the group of sauropsids way before we had gene trees. Like, sure, they can conflict, and I'm sure in many cases they do, but like they don't always. And it's we don't look at the morphology alone to do these trees. You factor in morphology and genetics together, right? So anyway.
All right. I found also
okay.
what I was looking for. There are things called developmental system drift, where you have a specific phenotype, which are homologous between organisms, but some of the underlying process has drifted away. Right? They were replaced by a different protein or something or whatever. And I have a paper here giving some more details.
That sounds kind of cool.
Yeah. Maybe we can discuss this maybe in some future video. It would be interesting.
I'm going to crush. I'm going to crush.
Of course.
Jim Wing. A few months ago, I suggested that a friend of mine, the sinister porpoise, who takes on creationists in response videos, I suggested that she would title those "Citation Needed." So
Citation needed. Correct.
I beat you to it by a few months. Sadly, she didn't want to do it.
Nestle,
Which
you know what always makes
I think is still sad, but there you go.
Yeah. Nestle, do you know what always makes me happy?
No.
I love seeing papers published on April 1st. That never ceases to give me a little chuckle. Sorry. Anyway. All right. Conflicts between phylogenetic trees, part 3. Ooh. When evolutionary biologists tried to construct a tree showing the evolutionary relationships between the 3 basic groups of living organisms, they failed. Do you mean domains? The 3 domains of living organisms? Because, like, we have a consensus tree. It's eukaryotes nest within archaea, and both are sister to bacteria. That's been consensus for like 30 years now.
I think that they were beginning to go into the horizontal gene transfer. Like a HTT is a thing. It is mentioned in the next and the next and the next. Yeah, it's
well, right, and that's true. However, like when he says 3 basic groups of living organisms, I assume that means the 3 domains.
Yeah, probably.
But and while there is HTT among all of them, obviously, that we have a consensus tree for all 3 domains. Eukaryotes nest within archaea, and both are sister to bacteria. That's the consensus tree, and again, has been for 30 years. I don't even understand. To attempt to explain this non-tree-like pattern. Well, okay. So let me step back for a minute. The origin of eukaryotes was not just natural selection, right? On acting on mutations. It was an endosymbiotic event. So it was horizontal gene transfer that resulted in the origin of eukaryotes, in a sense, right? It was a combination of an archaean, which was the progenitor cell, with which acquired a mitochondria, which was a bacteria, or is descended from bacteria, and that resulted in eukaryotes. Now, that event is not in and of itself tree-like, obviously. But nobody's saying that all of evolution necessarily follows a tree-like pattern, like a bifurcating tree pattern. Nobody's saying that. That is not a thing. But it's changed in the past, therefore it's not valid. Correct. Yeah, exactly. So yeah, no, that's just silly. Materialists appeal to a process called horizontal gene transfer, where microorganisms obtain genes through mechanisms other than inheritance from a parent. Why do they say they appeal? That it happens. We can literally observe it happening.
Yeah.
What do you mean? Appeal to this? When genes appear to invalidate a phylogenetic tree, evolutionists often think they can ignore the conflict, instead blaming it on HGT. What? That's just a lie.
We just made HTT up. It's like it's not like we observe. It's not like we observe it in, for example, in bacterial resistance to antibiotics. No, definitely not. Definitely not happening.
No, that doesn't happen. No, yeah. What is this argument that every time there's like a discordance between gene trees, the researcher's like, I guess it's just HGT again. That wascally wabbit always getting us. Like, what is this? What are they even saying? This is just nonsense. There are good reasons to question HGT as an explanation. Oh no. Oh no!
What are they? What are they? Let's
Well,
say
HGT can occur with some bacterial genes. It is highly unlikely to occur with all these essential genes. What are all these essential genes? What are they? What does that mean? What are you referencing? Why are there no citations for anything?
Also, even if it's highly unlikely, it still happens. Unlikely things still eventually happen, sometimes at least. So yeah, it's also interesting is that I think I also mentioned, like, when we were making the video on horizontal gene transfer for the genetic series. I put in a mentioning of Eugene Koonin's work and his work involved so-called nearly universal trees, plural trees of life. Right. And he looked at several bacterial and archaeal species and looked at what genes they universally or nearly universally share. And the nearly universal genes are genes involved in transcription and translation, the ribosomal genes and also ribosomal proteins in particular. And these genes are also very resistant to horizontal gene transfer, because when you swap the translational mechanisms, it obviously can mess things up in translation, and it has many different consequences. So these are the genes that are very resistant to horizontal gene transfer, but not completely immune. And also, interestingly, the phylogenetic signal in these universal genes are the strongest, because they are more immune to horizontal gene transfer, which is what you would expect from such genes. So it's completely consistent again.
Trudy Stubbs says it's just a rescuing device. Yep. Horizontal gene transfer, the thing we have literally observed, is just a rescuing device. Oh my god. Okay. Conflicts within the tree of life are also prevalent among more complex organisms, such as plants or animals, where such gene swapping is not directly observed. Again, cetacean, please give us one cetacean, any cetacean. Evolutionary biologists infer HGT through circular reasoning, where they assume HGT.
Are they saying that some animals like nest closer with animals or plants, like, and vice versa, or what are you saying with number two?
I assume they mean like within those groups there are like phylogenetic tree problems, and I guess.
Oh yeah, they're saying in the case of plants, you can have like they can do what's called like alloploidy, where two species basically hybrid, like this one species inherits the full genome of two species, and you can have like mergers like that, which we have observed in wheat. Like some varieties of wheat are allopolyploids. They have several genomes of different species. Full genomes. Like you have a diploid genome of one species and another diploid genome of another species, and just hybridized like that. Yeah.
Immutable Destiny asks a good question. That does make me ask, do we know of natural plasmids occurring that carry genes related to replication affinities like polymerases or ligases? I don't know. Nestle, do you know? Let's see. Nestle's going to look it up. We're going to find out.
Hold on. What's the question again?
Do we know of natural plasmids occurring that carry like genes related to replication affinities like polymerases or ligases?
That I don't know about specifically.
Okay.
No.
Well, I don't know. That's a good question, Immutable. I don't know. Evolutionary biologists infer HGT through circular reasoning, where they assume HGT causes conflicts in phylogenetic trees, then cite conflicts between phylogenetic trees as evidence of HGT. They ignore the possibility that the conflict exists because common descent is false.
You can still
that the conflict. Okay, so guys, let's talk about HGT for a second here, because There's some lies going on. Okay, so when microbes are doing HGT, they are not swapping whole genomes. They're like swapping like a few individual genes, right? Like a few, like a pack of genes, maybe. They're not swapping the whole genome. That's not what's happening. So when you're comparing like E. coli, for instance, a bunch of different strains of E. coli, and you see one of them has like 3 extra genes that none of the other ones have, and you sequence that, you put it in a database, and then it turns out that like Deinococcus, for instance, also has these genes and they're like nearly identical, then you can make the relatively reasonable assumption that this strain of like E. coli has or got those genes from a horizontal gene transfer event, ultimately originally from the Deinococcus, right? Like it's obvious. It's obvious. Maybe not always. Maybe sometimes you have like really ancient horizontal gene transfer events that happened, but in a lot of cases, you can very clearly tell, like, oh, this strain of bacteria got this gene or these genes from this other one because the other one still has them. They're swapping certain versions of genes for other variations of the same kind of gene. Yeah, right. They don't know we can understand when HGT occurs. Yeah, exactly right. Yeah, this is just bonkers. It's not that there is conflict. No one's like arguing that, this strain of E. coli that has the extra genes is not an E. coli. No one's saying that. They're saying, yeah, obviously the consensus of genes nests it within E. coli, but it also has these extra ones, which are most similar to Deinococcus, right? It's not that hard, and they're acting like we have no idea how to know that, which again, just flat out disingenuous. Nestle, do you want to add anything on that?
Yeah, I found like one of the papers by Eugene Koonin and colleagues that discusses this horizontal gene transfer and it's I can put the paper in the chat, and I can also quote like one the conclusion of this paper. It says horizontal gene transfer is pervasive among prokaryotes. Very few gene trees are fully consistent, making the original tree of life concept obsolete. A central trend that most probably represents vertical inheritance is discernible throughout the evolution of archaea and bacteria, although compressed cladogenesis complicates unambiguous resolution of the relationship between major archaeal and bacterial clades. So again, it says, of course, the picture is very complicated, but still there is a sign of common descent in the pattern.
Mm-hmm. Right. Yeah, no, this is just insane. This is actual insanity. Evolutionists assume similarity implies inheritance from a common ancestor, but that assumption often cannot hold true. Cetacean. Oh, look, they have a cetacean. Well, they don't really have a cetacean. They have another example. A striking example is marsupial and placental saber-toothed cats, which have many morphological similarities, which are thought to have arisen independently and were not inherited from a common ancestor. So, thought or like brain teaser, I guess. How do we know that those saber-toothed cats are in fact not closely related to each other? How do we know that? I'll give you a hint. It's the same thing we've been talking about. While there may be convergences, small-scale convergences, the overarching consensus of features is that they're not closely related. I know, crazy. It's almost like marsupials have like these holes in their palate that placental mammals don't, and like carnivorans have like a specific dental pattern that marsupials don't have. Crazy, right? I know, it's just bonkers.
And they also probably all talk about like Stylecosmilus, the extinct, even that, like there's also recent research that shows that the there is even the details of the teeth that are in Thylacolsmilus are very unlike those of Smilodon.
Right.
And the researchers proposed that they have a very different ecology. Like Thylacolsmilus was perhaps a specialist in feeding on the organs of perhaps even scavenging. Like it is a very different it's a very different way of biting. Even like maybe it wasn't even strong or even capable of hunting down things in the same way that the saber-toothed cats could. Yeah,
right.
It's very strange animal.
A lot of times the convergence angle is like played up, right? Because they want things to seem more convergent than they actually were. And like the thing about convergence a lot of times is organisms are like using different like they're accepting different parts for the same purpose a lot of times, same function. But it's or as you said, like even when they are when they do have convergence, it doesn't imply the same ecology or necessarily have the same function. So, yeah, nope. So it's just lies. Convergent evolution: two or more species independently acquiring the same trait, supposedly through Darwinian evolution. There are also many examples. So are they just saying convergent evolution is actually intelligent design? Is that what they're arguing? Richard Dawkins.
Perhaps.
It's kind of what it seems like, which again is stupid, but whatever. Richard Dawkins states it is vanishingly improbable that exactly the same evolutionary pathway would ever be traveled twice, but admits that there are numerous examples in which independent lines of evolution appear to have converged.
But these are not independent. Like for example, like all mammals, even marsupials, start out with the same basic body plan. So when they got isolated and evolved into similar niches, then you would expect some similarities to appear sometimes. But what if you would have an alien world, for example, with a very different body plans evolving? I wouldn't expect a lot of similarities. Perhaps the only similarities I would expect is like something that is physically necessary. For example, to evolve flight, you probably need something like wings, for example, of course. But but the structures, the underlying structure, will probably be very, very different. I wouldn't expect it to be very similar to like the tetrapod limb, for example, with 5 digits and such. No, I wouldn't expect that. And you can also see it in insects. Oh, you can also see that in insects. Like the insects evolved flight independently from the tetrapods, but they of course have a very different body plan than the tetrapods. But when tetrapods independent, like bats, evolved wings, they used one of their limbs, just like birds did, the front limbs. But of course, the details of how they were turned into wings are different too. Bats maintained 5 fingers and evolved a webbing between the fingers, but birds, they reduced their fingers and fused fingers even, and then the wing is mostly consists mostly of feathers. Very different design of that design, quote unquote.
It's just design. It's intelligent design, obviously.
Yeah.
I also think that this Dawkins quote is actually referencing 2 different things. The improbable the same evolutionary pathway should ever be traveled twice, I think, is a reference to Dollo's like law of improbability or whatever.
Yeah, I think so. Yeah.
Irreversibility. I think that's what that's referencing. Which is not about convergent evolution. It's about doing the same like mutations.
Yeah, you wouldn't expect it's the exact same species. Like if you 12,
which Dollo's law of irreversibility is not the same thing. It can be related to convergent evolution, but not necessarily. But yeah, convergent evolution is not contradictory to that anyway. So I don't even really understand what the argument is they're trying to make here. The main assumption of phylogenetic trees should be rewritten as similarity implies inheritance from a common ancestor, except when it doesn't. But what? That's it's not okay. Again, they're using similarity. It's sleight of hand, right? They're on the one hand, you have genetic similarities, which are like directly, legally evidence of inheritance. There's no arguing that. They're not arguing about that. They're arguing that morphological convergences happen, which is very different. And so they're just saying similarity implies descent, but look, convergent evolution happens in morphology sometimes, and that's similarity. This is a very dishonest and disingenuous argument they're constructing. What they're trying to mislead their viewers into saying, which is also really funny, because remember, Casey Luskin said we have to be straightforward about our definitions when they're not doing that. And he chided the evolutionist for saying evolution means multiple things, but when he's saying similarity here, they're implying multiple things. Sorry, Nestle, go ahead.
Yeah. Oh no worries. Like, but it's also statistically ignorant such a statement, because in statistics you often are dealing with individual data sets that don't match a trend, but when you look at the overall data set, you see a trend. So you can have exceptions to a rule, and they are saying no, you cannot have exceptions, which is stupid.
Right, exactly. Yeah, no, that's dumb.
Yeah.
There's a lot of disingenuity going on here. So, all right, common design. Biology provides numerous examples of highly similar structures shared by different organisms, which cannot be explained by except that can, but are unlikely to be generated repeatedly by natural selection. They didn't even explain why convergent evolution happens. It often happens because different organisms are in similar ecological niches. That's why convergent evolution often happens. Not always, but often. And so they didn't even talk about it. They didn't explain why. They just glossed over it.
Although I'm trying to reread exactly what they're saying. Can you repeat that? The sentence that's saying, yeah.
Biology provides numerous examples of highly similar structures shared by different organisms, which cannot be explained by common ancestry, but are unlikely to be generated repeatedly by natural selection.
I don't know what they are referring to there. Yeah.
I also don't. Maybe
what structure? Yeah.
Common design is often the best explanation for the cases of supposed convergent evolution. Citation needed.
If that's the case,
even when functional.
If that's the case, then why don't all animals have the exact same eyes?
Yeah, why don't vertebrate and mollusk eyes? Why aren't they the same? Why are they different?
Yes, if there was such a thing as common design, then why design things in different ways, doing the exact same thing?
Immutable says, can you give an analogy with cars about how HGT occurs? I'm analog using it to a paint job, but some might argue it's more like swapping out the engine. Yeah. So again, like, if you swap out the engine between two cars, the overall, like the consensus of parts are still the same, right? Yeah, it's a different engine, but everything else is the same, right?
I think the analogy is it's very difficult because like you can you talk about genetics, and cars doesn't have something similar to genetics, but
I mean,
I
that's
think
true.
I think a better analogy would be languages. Like you in English, you see many terms that have originated from Germanic languages, but you also see the insertion of many Latin-based languages.
So
like,
I'll give an example. So like with that, like the word sushi. Sushi is a Japanese word, right?
Yeah.
But
Also,
it's in English. So would we be justified in arguing that we cannot prove that English is a Germanic language because sushi is in the lexicon?
That's a very good example. Yeah.
Yeah.
Sushi proves that English is actually Japanese.
Correct. Yes. Yeah. I think I might use that as an argument. I really enjoy that one.
Yeah.
But yeah, and you can make, literally thousands of examples, things like that. The term samurai is another one. Gosh, like croissant or croissant. Yeah, all these different things. These are all words imported into English from other languages. And so it would be like looking at those words which we imported from other languages, which we all know, and using those to say, well, actually, English is not Germanic by descent. Like, no, that's not how that works. You can't do that. We have the I understand that Nestle, but creationists like cars. That's true. They do. They prefer their car analogies. I do really like the language analogy. When everyone is a weeb, no one is. Dalton,
it's just that the process that gives rise to languages is very similar to what happens in genetics. Like even the same linguists use even the same methodology to reconstruct ancient languages too, like the concept of homology, even, I think, right? Probably, or probably something similar. Yeah.
No, yeah, definitely. Like, looking at the similarities in like roots and stuff between words of different languages. That's why I like the word Rex in Greek and Raja in India. There, I don't remember what language, Hindi, if I remember correctly. But like, it's the same root word for both. Actually, I think cannabis and balsamic are the same way. It's the same root for both cannabis and balsamic, if I remember correctly. But stuff like that, right? And these all go back like thousands of years to like Proto-Indo-European culture and that sort of stuff.
Yeah.
Which is also really cool. Maybe we should do like a series on Proto-Indo-European culture at some point.
Yeah, you have to ask Dapper Dino, because he is really into linguistics.
That's true, he is.
Yeah.
Linguistics is scary, I'm not going to lie. We did a little bit of linguistic stuff when we looked at whose tale was that? No, it wasn't the handyman. Ergast. It was the Ergast tale. We talked about language. Guys, I don't know if you have read papers on linguistics. It's some scary stuff. It like borders into philosophy, which is also scary.
I've read a few things, and it's very interesting how like surprisingly they can reconstruct some of the culture that the Proto-Indo-European had. Like it's like for example, a very famous example is the Latin term for God is Deus, as in Deus ex machina.
Right.
But it has the same etymology as Zeus, of the Greek god of the pantheon, basically the main god. But also Jupiter. But although Jupiter, in the case of Jupiter, it also contains the term for father. Basically, the original.
Right. It's like Sky Father.
Yes, exactly.
Right.
Jew. The first two letters of Jupiter is Jew, or which is similar to the Zeus or Zeus and Deus. And then if you go back to the Proto-Indo-European thing, you get to the Deus Pater, basically Sky Father. Yes,
right. Which is really funny. And what's so funny about that, because there was a it was like Religion for Breakfast video about it, I think, or something like that. Which, if you guys haven't seen Religion for Breakfast, highly recommend. Go check out their channel. I think he did a video about that at one point, and it makes me laugh because like the Reddit atheists used to say like Sky Daddy, you know?
Yeah. Yes.
And what's so funny about that is like Sky Daddy is literally the translation for this.
Yeah.
Also, where the word Dalton says also where the word day comes from.
I think so. Yeah. Yeah. Day. Yeah.
Yeah,
Like the term they use has many different descendant languages, and they also like in some languages you have words for bright or sky or light, daytime, and something like day, like many different related terms for basically referring to the daylight or the daytime sky. Which was perhaps deified in the Proto-European language. They worshipped or they viewed the sky as a divine entity. But they also viewed. There's also interesting etymology when it comes to Earth. The original term or the Proto-Indo-European term for or where the term human and also in Latin homo. It's the same etymology in English too. Human and homo share the same etymology. And if you go back, you see that the term originates as earthling.
Really?
Yes.
Okay.
Earthling. Like literally, people from the earth. That's what comes. Like it's also, I think, how do you call again? Humus. The Latin term for earth, basically, also has the same etymology. Yeah.
Interesting. That earthling. That's great. I love that.
Yeah.
Because so I guess the aliens, they came here like 70,000 years ago, and then when they came back, they were like, "Greetings, Earthlings," for that reason, I guess. Okay.
Exactly.
Oh well, we're getting pretty close to correct. Does religion for breakfast come with a side of pasta and meatballs? May His Holiness be upon us. Yes, ramen. All right. So we have about 5 minutes, so I guess we'll call it for today.
You wanna scroll down to the end of this particular part, or?
Well, we have like 4 minutes. I don't really have time to go through.
I think that was it.
We'll just pick up with this next time. We'll just pick up with this one next time, and we'll finish this out, and then we'll go to the next one. Actually, well, next week I said we're going to do Meyer and Rogan, which we won't get through, but because it's going to be like over an hour probably, because his interviews are usually over an hour. Anyway.
Yeah, I think I saw it was 55 minutes.
Really? It's only 55 minutes? That's pretty short for a Rogan interview. He usually does like at least an hour. Huh. Okay.
I don't know.
That's fine.
I'll have to go back and check.
Hey, listen,
and need
no
to
problem
figure out a way to download it so I can stop and start it and make sure that the sound goes through everywhere. So I'll see what I come up with.
Okay, gotcha. Alrighty. Well, what are you guys up to in the upcoming future?
Well, nothing much.
Nothing much. Same old, as it were.
We have completed the script for our next video.
Correct. Yep, the Narrowmouth's tale is soon coming, I guess. Yeah. What about you, Peter? What you got going on?
I'm still so at the moment. So I do 4 shows a week, not even counting my own channel. So we read the Bible on Wednesdays and Saturdays, and then the Book of Mormon on Sundays. This Wednesday we're not going to do a show because Arn is going to be in Cancun in Mexico, so we're not sure if we're going to skip that or do a different day. But it's going to be pretty difficult for Arn to do a show from Mexico, although he's trying to do it on Saturday from his hotel room, I think. But yeah, if you haven't checked out Blasphemer's Bible and reading Joseph Smith, you're missing out. both are fun shows. And then we are setting up, I think, 5 shows between Arn and the creationist on the panel of Blasphemers Bible P-Town on specific topics. I know that abortion is one, and I recently came up. Yeah, I recently came up with a thought experiment for people who call themselves pro-life, and I won't go into it. I did test it on P-Town, who went completely silent when I came up with this, and Arn said, "We need to do this in the live show." So I'm going to throw that in when we tackle that one. But he's got several things that came up while we were reading the Bible that he said, "I want to talk to you about this." So there are a couple of interesting shows coming up on Arn's channel, and yeah, as I prepare about an hour in advance, and then we usually talk a little bit after the show. That's 8 hours a week that I'm pretty much busy doing streams. So it's a lot.
Okay, cool.
Do you by any chance know if Arnold is going to do another like evolution video like he did with the arachnids, or no plans for that?
I know that Arn's schedule is pretty busy at the moment. So as I said, he's traveling to Cancun. He also is attending some kind of convention in Washington State. I think next week or the week after that. And yeah, then we have the shows that we do every week. It's a lot of work, and he also had some things going on in real life. So I'm not entirely sure if there's anything specific coming. So we'll have to wait and see.
We got a super chat from Jake Nelson for $10. Says a super chat just because it's been a while. Love you guys. Thank you very kindly. Much appreciated. Alrighty. Well, fantastic. Okay. Well, we're just past the 2-hour mark. So so next week we're gonna do the Rogan Meyer interview, and then after that we'll probably come back to this and finish these lessons, quote quote, out. So we've got some material for the next few weeks, don't we? So that's good.
Apart from that, we still have 2 other shows as well. So we're probably good for a month and a half, maybe even 2.
Well, good. There you go. We thought ahead.
There's a lot of stupid still to tackle.
There's always a lot of stupid to tackle. So on that note, well, thank you everybody for watching.
One quick thing.
Everybody live.
Nestle, one of the topics that Arn is going to cover with the creationist is evolution. So people who still deny that is a fact, that might be a good one. Evolution 101 with someone who actually denies.
It will be live, right?
I volunteered to produce them, so if that's going to be the case, it's going to be live. So,
all right, it'll be interesting to watch.
Yeah.
Alrighty. Well, thank you everybody for watching, and thank you guys, Nestle and Peter, for being here. I always appreciate you, and we will see all of you next time.
Bye everyone.
Everybody.